So the next section is the fill in the blank section, or fill in the chart for the atoms and the ions. Notice that I differentiated. Ions are those which have a charge on them, so this one has to do with change from the normal number of electrons, right? A little technical difficulty here. So changing in electrons, or change in electrons. All right, so this one up here, we just assume, since it doesn't say anything about a charge, we assume that the protons and the electrons are even. All right, so that brings us to the nuclear. This element here is atomic number is 14. You go to your periodic table, you find element 14, it's silicon. If you need a periodic table, there's one on the front page of the web page. You could open it up in a separate window. Okay, atomic number is 14. We said earlier that atomic number is equal to the number of protons. The electrons equal the protons if there's no charge. The mass here is 27, so the protons plus the neutrons equal the mass. So we know that 14 plus something equals 27, so that'd be 13. And then the hyphen notation would be silicon 27. Down here, we've got 83 electrons. So if you look at your periodic table, you'll find that 83 electrons, oh, by the way, that'd be 83 protons as well, because these are neutral, so they've got no charge. 83 protons is bismuth. The symbol for that is Bi. All right, the atomic number is the same as the proton, so that'd be 83. The mass number would be 83 plus 125. So if I add those together, I get an 8, I get a 0, I carry 1, I get 208. So my hyphen notation would be bismuth 208. Now rubidium 88, the symbol for rubidium is Rb. Atomic number for rubidium, if you look at your periodic table and find Rb, it's 37, I believe. We're going to double check. Yes, it's 37. So its mass number we know is 88. The protons would be the same as the atomic number, 37, and the electrons equal that as well, because this is a neutral atom. Then to find the number of neutrons, it would be 88 minus 37, because protons plus neutrons equals mass. So 8 minus 7 is 1. And 8 minus 3 is 1, or it's 5, I mean, so we have 51. So that number here would be 51 neutrons. Down here, we're dealing with ions. So this is a change in electrons, not the normal number. Okay, here's zinc. Its nuclear symbol is Zn. And then these, we're going to put the charge and the mass and everything and do them really right. So the zinc is 65, but its atomic number is 30. And we put that down. And we know that just by looking at the periodic table. The mass is given here as 65. The number of protons is the same as the atomic number is 30. The electrons, it tells us we've got a +2 charge. That's its charge. And it tells us that here, so that means we've, lost or gained electrons? It can be lost if you're positive. So we're really looking at having 28 electrons instead of 30. And the number of neutrons would be the protons and neutrons together, 65, minus the protons, 30, so you'd have 35 neutrons. Okay, this is one that we did in a quiz. This next one, this is 18 electrons, but it has a -3 charge. So that means 18 includes 3 extra. So if there are 3 extra, then normally you would have 15. Which would mean that you have 15 protons. If you know that you have 15 protons, that tells you the atomic number is 15. If the atomic number is 15, the element's phosphorus. The mass on this phosphorus would be 15 plus 16, protons plus neutrons, 31. So we'll put that over here. And the charge, it tells us is -3, so we put a little -3 right there. The next one, the atomic number is 19. That tells you that the symbol's K. So you go to your periodic table, you find 19, and it's K. The protons in must be 19. And we're given the electrons as 18. So we know that means since we have one more positive than we do negative, or we've lost an electron, we have a +1 charge. Neutrons would be 41 minus 19. So what's that? 22. And then over here, to fill in the rest of our symbol, we'd have a 19, we'd have a 41, and we'd have a positive 1 charge. And that leaves us one more question. So we have a number of electrons is 18, but that's a minus 2 charge. So that includes how many extra? 2 of them. So the normal number would be 16, which means you'd have 16 protons. The mass number, it tells us, is 35, so I'd have to take 35 and subtract 16 to find the number of neutrons, so that would be 19. The atomic number is the same as the protons, that'd be 16. The symbol then sulfur, 16, 35, with a negative 2 charge. And that's the end of the little grid section.